Hey, it's Mr. E here. Our aim for this video is how do we write logarithms as exponential equations and how do we apply the change of base rule. Okay, so a logarithm is an exponent, and to consider this I want us to look at this example. We have 2 to the third equals 8. 2 to the third equals 8 is an exponential equation that's made up of a base. It's made up of an exponent and an answer. And this can be rewritten as a logarithm. Now, I'm going to show you how it could be written first, and then I'll break it down. So if we're going to rewrite 2 to the third equals 8 as a logarithm, it would be written in the following way, as you see here. Now, this is read log base 2 8 equals 3. So this is our base 2, which was our base here. Now the answer switched sides and it's now here, and the exponent is now here. Okay, so in general terms, we can say that log base b x equals y can be rewritten as b to the y equals x. So here we went from an exponential equation to a logarithmic equation, and here we're going from a logarithmic equation to an exponential equation, but this is just in general terms. Okay, let me show you a way to remember how to go from logarithmic to exponential. So if you have log base b x equals y and you want to go to exponential, you just follow the arrows. So that would be b to the y equals x. Follow the arrows. Okay, so this was just a discussion on how to go back and forth, from exponential to logarithmic and from logarithmic to exponential. Now let's put some of this into practice. So here we have example 1, and it says write 4 to the 5th equals 1024 in logarithmic form. Now if you recall from our previous discussion, b to the y equals x can be rewritten as log base b x equals y. So 4 to the 5th equals 1024 can be rewritten as log. Now the base is going to go here. The base is 4, and the answer is going to go here. That's 1024, and the exponent, which is 5, is going to go here. So 4 to the 5th equals 1024 can be rewritten in logarithmic form in this way. Try this example. See if you can work it out on your own using what we just learned. Okay, so one way to do this is to rewrite this as an exponent. Now, if you're going to rewrite this as an exponent, you're just going to follow the arrows. That's just a way to remember it, I suppose, if you're having trouble remembering how to write it as an exponent. So that would be 5 to the second power equals x. 5 to the second power is 25, so 25 equals x. Now, the question I suppose that you should be asking now is, how would you check this? Because now that we know that x is 25, that means that log base 5 25 equals 2. However, though, let me point something out. In your graphing calculator, you can't type in log base 5. The calculator only does logarithms in base 10. Even though you don't see a 10 there, the calculator only does logarithms in base 10. So it goes back to this question, how then do you check this? I want you to just keep that in mind. We're going to come back to example 2 a little bit later on. So let's leave this question open for now. How would we check log base 5 25 equals 2? So put that question in your back pocket. We're going to come back to it. Okay, here's another example. Calculate log base 5 31 25. Well, this is the problem that we had from before, that the calculator only does logarithms in base 10, and that's the only base the calculator does logs in. So one way that we could calculate this is to use what we call the change of base formula. So let me give you the change of base formula. Log base BA is equal to log A log B. Now, I know that it doesn't have a base here, and let me explain why you don't see the base there. When it's just written log, you assume that the base is 10. So technically there's an invisible 10 here and there's an invisible 10 here. But it's not written there because it's already assumed that you're in base 10 if there's no other base written there. So this is the change of base formula, and we're going to use this to calculate this logarithm. So using this formula, this part here would be our A, and then this would be our B. So it would be log base 10 31 25 over log base 10 5. Now I don't have to write that 10, remember, because it's already assumed that it's 10 if there's nothing written there. And this is something your calculator can do, because the calculator could work in log base 10. So it's log 31 25 over log 5, and this is equal to 5. So log base 5 31 25 is equal to 5. Now there's a couple of ways you can check this. One way to check it is to put this back in exponential form, and that would be 5 raised to the 5th power. Check if that equals 31 25. Let's see. So 5 raised to the 5th power, that is indeed 31 25. That's one way to check it. Another way to check it is to check it with the change of base formula and just do log 31 25 over log 5 and make sure that gives you 5. All right, let's go back to example 2 now. Remember, we were trying to check log base 5 25 equals 2. Well, you can check this using the change of base formula. So check to see that log 25 over log 5 equals 2. Check check if this is accurate. So log 25 over log 5. Let's hope that's 2, and it is 2. And you can also check it by going back to exponential form. And that would just be 5 squared. Check that that goes to 25, and it does. Okay, so now I want you to try these two examples. If you don't want any hints, I suggest you stop the video now. And if you want to hear the hints, keep playing the video and I'll give you some hints. Okay, so for number 1, I would put it in exponential form. Okay, and you know, after putting it in exponential form, you'll see that you're able to solve for x. If for number 2, here's what I would do. I would take the numerator, use the change of base formula for the numerator, change of base formula, and I would also use the change of base formula for the denominator. Whoops, I meant to write change of base formula there. Maybe I can just do a copy and paste. So I would use a change of base formula for the numerator, and then I would use the change of base formula for the denominator and divide it and get an answer. Okay, if you want to know the solutions to these two problems, you're going to have to wait till you see me in class tomorrow. Okay, have a great day. I hope these videos help. Take care.